Okay, students. Today I am going to discuss about the variations of bond length in different molecule. Okay, like you can see, there are lots of molecules, and the bond length will get changed. It will get varied if we change the substituent. Means if we change the atom, whether we will substitute it by electropositive element or electronegative element. Okay, that will give you the change in bond length. Okay, so here in N2H4, in N2H4, in N2H4, here the bond length between Nn and the bond length between Nn will be entirely different. Okay, in C2H6, the CC bond length here it will be different than CC bond length in C2H6. Likewise, OO bond length in O2H2 and OO bond length in O2F2 will be different. CCl bond length in CH3Cl and CH3Cl will be different. Okay, here BB bond length, here BB bond length. Okay, here NO bond length, here also NO bond length, and here IO bond length, and here also IO bond length, and here NN bond length. Okay, and in this case S double bonded O is length. Okay, it will be entirely changed. যদি আমরা substituent change করি, এখানে hydrogen gets substituted by fluorine. Okay, electronegativity of fluorine is more than hydrogen. তাহলে এখানে bond length completely change হয়ে যাবে। কার ক্ষেত্রে বেশি হবে? Which one will be longer and which one will be shorter? That we will discuss in detail. Okay, these are the very interesting examples. Okay, apart from that, we will discuss about the axial and equatorial bonds in octahedral TBP, I mean trigonal bipyramidal, and in pentagonal bipyramidal geometry. In octahedral TBP and pentagonal bipyramidal geometry, where the most electronegative elements will be positioned, or where will be the locations of most electronegative element, and the bond length variations, that I will also discuss. And this also an interesting example, PCl5 and PCl3 F2, the bond length variations here in PCl. Okay, and ClF3, BrF3, SF4, ACF4, SF6, and in SF2. And one more example like this one, if this bond length is A, this is B, and this is C, then that also we will compare. Okay, so before I discuss in detail about the bond length variations in each case, let me briefly tell you about the Bain rule. See, in my last lecture, I have discussed about the Bain rule in detail. Please go through that video, then you will understand this lecture very well. Okay, so first, for Bain rule, I will write it again. Bain rule says that most electronegative element, okay, most electronegative element prefers to stay in an orbital where percentage of S character is less. So more electronegative element will prefer to stay in an orbital where percentage of S character is less. Okay, this is one statement. And one more, that lone pair prefer to occupy in an orbital, where percentage of S character is more. Okay, these are the two statement of Bain rule. Okay, no problem. Now percentage of S character basically, okay, let me write one thing, that percentage of S character is proportional to bulkiness of the orbital, bulkiness of the orbital, closeness to the nucleus, closeness to the nucleus. Okay, inversely proportional to bond length means percentage of S character increases, bond length decreases, and percentage of electronegativity increases, coil, that is electron negativity, also increases. Please remember all these things. And one more thing, that percentage of S character is directly proportional to bond angle, means bond angle increases, percentage of S character increases. There is one formula that is cos theta is equal to S divided by S minus 1. If theta increases, percentage of S character increases. So if you are confused with the theta and percentage of S character, so it will go through like this one. See people want to say here this is sp hybridized orbital, so bond angle 120. Here like CH4. Okay, this is sp3, bond angle 109 degree, 20 like that. So percentage of S character increases. Here 50% S character, bond angle also increases. Here bond angle is 180 degree. Okay, done. No problem. Okay. Now let me show you one thing, that say this is S orbital. This is S orbital. And this is the hybridized orbital. Say this is sp. This is S. Okay. This one is sp2. Okay. This one is sp3. sp3. And this one, say this one. Okay. Okay, this is the orbital. Now look at here. Now look at here. See, like this. This is the nucleus. This is nucleus. Okay. See, you can see that as the percentage of S character increases, percentage of S character S character decreases from here to here. Percentage of S character decreases. Orbital gate, thinner and longer, Okay. What I am trying to say, if fluorine wants to, say fluorine is the electronegative element, right? Most electronegative element. Fluorine wants to form a bond, of course with hybridized orbital. It will prefer to form a bond here. Means less S character, less percentage of S character. Why? Because see, if fluorine form bonds with this hybridized orbital, the distance, see, this is the electron cloud, this is the shared pair of electron. So distance from this nucleus will increase, and fluorine will be happy with delta minus, because it will get maximum delta minus in this hybridized orbital. Okay, no problem. Okay, so most electronegative element will try to form a bond, because distance will increase in orbital where percentage of S character is less, and lone pair will be under the influence of one nucleus. So lone pair will try to occupy or in a orbital where percentage of S character will be more. Like here, lone pair will be happy with more percentage of S character hybridized orbital. Okay, this is one statement. Now, if you look at octahedral, if you look at octahedral, PBP and pentagonal bipyramidal geometry. Okay, in this three geometry, what will happen? Where lone pair will be, where lone pair and the bond pair will be the placed or will be positioned. Where we will put the lone pair and the bond pair. Okay, in octahedral geometry, and that will be determined by angle. That will be determined by angle theta. Theta increases, but theta will be more. Lone pair will be placed over there, and if theta is less, electronegative element will be placed. Okay, no problem, because theta increases, percentage of S character increases. So lone pair will be placed in orbital where percentage of S character will be more. Okay, in octahedral geometry, say in octahedral geometry, okay, in SF6, see, first of all, if percentage of S character changes, the bond length will get changed. Percentage of S character increases, bond length will decrease, and percentage of S character decreases, bond length will increase. Now look at here in SF6. If we talk about the bond length of, say, this SF bond length and this SF bond length, whether it will be equal or different, or which one will be the longer. See, in order to do so, you need to see the angle, check the angle. Okay, in this case, basically angle is here 90 degree. This is square plane and this is axial positions. So here angle is 90 degree. Here what's the angle? 90 degree. See, here all the angles are 90 degree. If all the angles are 90 degree, bend rule won't be applied. So in this case, as all the angles are 90 degree, there will be no change in bond length. Means all the SF bond length will be equal and bend rule won't be applied here. No problem, because all the bond angles are equal, and we know that percentage of S character increases, then bond angle increases, bond length decreases. But here all the bond angles are same, so no need to bother about the variations in bond length. All the bond length mean SF bond will be equal here. Now come to TBB geometry. In TBB geometry, okay, I will remove there. In TBB geometry, say PCL5. In case of PCL5, see, okay, this is PCL5, TBB, trigonal bipyramidal. Okay, in a PCL5, there are two types of angle. When there will be two types of angle, there will be change in percentage of S character. Okay, beta? So percentage of S character will be changed. See, what is angle here? This is 120 degree. And this will be 120 degree. Right? In this plane, this is trigonal bipyramidal. This is equilateral. And this is equatorial bond, and these are the axial bond. Okay, and one more angle is there. That angle, it's like this. Here, this angle is 90 degree, and this angle also 90 degree. Now look at very carefully what I told. The theta increases, percentage of S character increases, bond length decreases. So in this case, here theta is more, So this is equatorial bond and this is axial bond, and here theta is less. Okay, so if we want to compare that PCl equatorial bond and PCl axial bond, what we will say in the geometry? We'll say that axial bond will be longer than the equatorial bond, because in axial bond the angle is less. Angle less means percentage of S character less. Percentage of S character less means bond length will be more. That's why in PCl5 the axial bond is longer than the equatorial bond. Okay, no problem, no problem. Now come to pentagonal bipyramidal geometry. In pentagonal bipyramidal geometry, the case is little bit different. Little bit different. In pentagonal geometry, the case will be like, okay, okay, let me change the, sorry. Okay, fine. Okay. In pentagonal bipyramidal geometry, say IF7. Say IF7. In IF7, what will happen? In IF7, beta, let me draw that IF7. I, CJ, 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 CJ. In pentagonal bipyramidal geometry, the scenario will be different from this case. Okay. In pentagonal bipyramidal geometry, let me first write the angle. Here, angle is 90 degree. This angle is 90 degree. And here all the angles are 72 degree. 72 degree. So in this case, you can see here in equilateral plane, here the angle is 120 degree. However, and this angle is less than the 90 degree. In this case, it is different. With axial and equatorial bond, the angle is 90 degree, and with equatorial bonds, the angle is 72 degree. 72 degree means here percentage of S character is less, and here percentage of S character is more. So if we compare this IF bond, say this IF, and this IF, what will happen? This IF bond length will be the shorter compared to this one. So in this case, IF axial is shorter than IF equatorial. No problem. Here equatorial bond will be longer because angle is less. Right? You just try to remember this one. Okay? Is that clear to you? Hope it's clear to you. And it's clear to you. Now we are going to see the variations in bond length if we change the substituents. When we change the substituent, then what will happen? Okay, please take the screenshot. Okay, fine. Now, one more interesting thing, that when you will compare the bond length having 4 or 2 different types of bonds, then what will happen? The percentage of S character or P character in the bonds will be different. In every bond, the percentage of S character or P character won't be the same. Okay, let me show you one interesting thing. Like, say this is central element. This is a bonded element X, and this is bonded element Y. Okay, that's clear. This is central element A, bonded element X, bonded element Y. So it has some percentage of S character here. It has also some percentage of S character here. Okay. Let me draw the orbital like this. Okay, this is the hybrid orbital. Pay attention over here. Now, if we replace Y by more electronegative element, what will happen? Okay, if we replace Y by more electronegative element, what will happen? See, A is X. See, when we replace Y by more electronegative element, the percentage of S character in this orbital get decreased. Say, we will replace this Y by F. What will happen? If we try to be in an orbital where percentage of S character is less, what I showed earlier, that percentage of S character less means orbital will get thinner. Orbital will get thinner and longer. So, in this case, the orbital will be like this, from here to here change. If the percentage of S character from here to here means here to here, percentage of S character decreases. No problem, percentage of S character decreases. But total percentage of S character will remain same. In that case, what will happen? This bond will do an adjustment in order to make the total percentage of S character same. So in this case, if the orbital, say before it was like this, so here percentage of S character decrease and here percentage of S character will get increased. So how does it look? It looks better like this. See, total percentage of S character, here say 100%. Here also total percentage of S character 100%. It won't change. Total percentage of S character won't change. But the bond will do that adjustment. If in one bond it will be decreased, then another bond it will increase. Okay. So this is very interesting. So what I am trying to say, and now going to conclude one thing, that when you replace this Y by more electronegative element, then what will happen? What will happen about this bond length? This bond length will be shorter. So AX bond length here and AX bond length here. Say here 1, here 2. Then what will happen? This is the AX bond length. And AY bond length. If you see here AY bond length, say here 1 and here say AY2. So AY2 will be more than AY1. See here percentage of S character decreases, bond length increases. Percentage of S character increases, bond length decreases. Up to now, hope it's clear to you. See, if you clear this point, then it will be very easy to compare the bond lengths which I showed you earlier. Okay? So this is okay? No problem? No problem. Okay. And now, move to one example and we will see that example. Say, look at carefully. This is CF4, this is CHF3, this is CH2F2 and this is CH3F. What will happen? if we change the F by H, you can see that CF bond length gradually increased. CF bond length increased means here CF bond length and here CF bond length, here CF bond length and here CF bond length changed. Now whether it will increase or decrease, how we can explain that one? See, here in this case, draw the orbital. Say this is sp3 hybridized orbital, sp3 hybridized orbital, sp3 hybridized orbital. See, in this case, there won't be any change. All the hybridized orbital will be equal. Here, all the hybridized orbital will be sp3. Now, if you move from here to here, what we did? We just replace F by more electropositive element. So when you will replace F by more electropositive element, what will happen? The percentage of S character will increase here. Percentage of S character will increase here. Okay, no problem. See, if we replace one element, see, in this case, like in earlier case, if we replace Y by F, what you have seen? Like this. Now, if you replace say Y as number 2, Y by say H, less electronegative element than Y, say like this. Do you get my point? If you replace Y by F, this hybridized orbital percentage of S character will be less. So bond will be elongated, means bond length will be more. And if you replace Y by H, what will happen? Here percentage of S character will be more like spherical. Percentage of S character will be more. Here I will write one thing, that electronegativity of hydrogen is less than electronegativity of Y, and here electronegativity of fluorine is more than electronegativity of Y. Okay, this one clear. So if we replace F by H, the percentage of S character here will get increased. Okay, so how I draw that? So in order to show the percentage of S character increased, let me do it more like spherical. Increase. See, what I told you, if in one bond percentage of S character decreased, then other bond they will compensate that one. Means here percentage of S character increase, means other three bonds it will decrease, so the total percentage of S character remain 100%. See, is that clear? Total percentage of S character 100%. See, if it's not clear, see, here 25% is, don't get confused, 25% is, here 25% is, and here also 25% is. 25% is. So 25, 100%. Now, if you increase here 25 to say 28%, say 28%, then what will happen? 3% will decrease in each bond. If percentage of S character decreases, then bond length increased. Okay, I will show you how that orbital will get changed. See, if percentage of S character initially it was like this. Now it became longer and thinner. So percentage of S character decreases. So bond length now it will increase. Did you get my point? Now if you replace one more F by one more H, again here percentage of S character like increase, and percentage of S character, here percentage of S character decreases, so bond length will increase. Means this orbital now it will look like this. This orbital look like this, longer and thinner compared to this one. In this case, what will happen? In this case, again percentage of S character here increased. So here percentage of S character decreases. So bond length will increase. Did you get my point? As you replace electronegative element, more electronegative element by more electropositive element or less electronegative element, what will happen? Percentage of S character in this bond will increase and percentage of bond in these bonds decreases, bond length increases. See, I will, if you still, it's not yet clear to you, I will show you like some data, arbitrary data. Let me show you or let me explain by taking some arbitrary data. Then hope it will be clear. Say here percentage of S character 25%. Say it will be fine, 25%. Now what I will tell you, from here to here, if you come, from here to here, if you come, then what will happen? Percentage of S character here, it will increase. See, if percentage of S character increase, let me write, then what will happen? Say, this percentage of S character increase 25 to 28. Say 23% increase. So 28%. Now, what will happen? The 3%, whatever it increased here, exactly the 3% will decrease here. So here S character will be 24%, 24%, 24%. So now let us see. Percentage of S character decreases, bond length will increase, bond length increases. Now next move to here. So now this is 20%, 24, 24, 24, no problem. Now keep it 24, 28, don't disturb it. 28%, don't disturb it. Now if you replace this one by age, what will happen? So 24 to say 26, say 26. So okay, this is 26% now. If it is 26%, means 2% increased, then 2% will decrease here. That means here it will be 23%, 23%. Here also it will be 23%, no problem. So total you can get it like 100%. 8, 6, 14, 17, 20 and 2, 4, 6, 8, 10. No problem. Now if you, now keep it here 28, say 28%, don't disturb here. Now here it's a 26% here. Now if you again replace this one by age, then what will happen? Say here 24%, say here 24%, then what will happen? It will be 22%. It will be 22%. Okay? So if you see that, if you see now these bonds, now see this bond. Here percentage of S character 25%. Here percentage of S character 24%. Here percentage of S character 23%. Here percentage of S character 22%. So percentage of S character decreases, bond length increases. Please try to understand this one. If you understand this one, then other examples, what I am now going to show you, it will be very easy to explain. Okay? Okay, no problem. Now, next move to here. Now, I'll show you like change in bond length N to H4 and N to F4. Now, I'll do it first. You can do it now, no problem. N to H4, N to, say this is N to H4, N to H4 and N to F4. Write it here. N to F4, N to F4, F. Okay. Now, what will be the bond length? If bond length here x1 and bond length here x2, what will happen? See, H get replaced by more electronegative element. So what will happen? What will happen from here to F? Percentage of S character decreases in this bond, percentage of S character decreases in this bond because A is replaced by F. Mode electronegative element beta, mode electronegative element will prefer to occupy in orbital where percentage of S character is less. So what will happen if percentage of S character here less? In order to make it 100%, so percentage of S character in this bond will increase. In this bond will percentage of S character increase. If percentage of S character in this bond increases, then what will happen? The bond length will be shortened. So x2 is less than x1. No problem. x2 is less than x1. Move to next example. Okay. Now move to next example. This is the example. Okay. C2H6 and C2F6. C2H6. Very simple, beta. Now it will be very simple to do. C2H6 and C2F6. F. This is F. This is F. No problem. Okay. Hydrogen replaced by fluorine. So fluorine will be preferably in orbital where percentage of S character is less. So in this bond, percentage of S character less. Percentage of S character less. So how it will be compensated? So if percentage of S character in these three bonds decreases, then here percentage of S character increases. No problem. So if this bond length, if this is x1, this is x2, we can write that x2 is no problem. Okay. See here you can F or Cl. In some questions it will be given like Cl, so don't worry about it. Okay, bond length will be varied, but this will be same. Okay. Now O2H2 and O2H2. Now O2H2 and O2H2. Very simple. O2H2. This is O. This is H. This is H. O. F. What will happen? A is replaced by fluorine. So here percentage of S character decreases. Here percentage of S character decreases. If percentage of S character decreases here, then here percentage of S character will be increased. So if bond length is x1, if this is x2, then x2 is less than x1. No problem. Is that okay? Is that clear to you? Okay. Thank you. Next. Okay. Now next move to B2Cl6 and B2F6. Okay. This won't be B2Cl6, beta. This will be B2Cl4 and this will be B2F4. Okay. So B2Cl4 and B2F4 like exactly same. I'll do it first. Like here B2Cl4, right? This is B2Cl4 and this is B2F4. What will happen? See here Cl get replaced by F, mode electronegative element. Percentage of S character decreases, so percentage of S character increases. So bond length, if it is x2, if it is x1, then x1 is greater than x2. Okay, no problem. Now next, what is there? Okay, now next move to this one. Okay, NMa3O and NF3O. This is also like very simple. NF3O and NM3O. Okay. N, this is O plus Me. This is N plus O minus. Okay. F. You can see here. So less electronegative element replaced by more electronegative element. Okay. So Me get replaced by F. So what will happen? Here percentage of S character decreases. Here percentage of S character decreases means here percentage of S character will be increased. So if percentage of S character is bond length, shorten. So if the bond length here it is x2 and here it is x1, then x1 is greater than x2. Right? No problem. Okay. Now move to the IO bond in IF2O2 minus and IF3O. Okay. IF2O2 minus, sorry, IF2O2 minus, IF2O2 minus and IF3O. So how does it look? See, mode electronegative element, axial positions, oxygen minus, this is double bonded O and lone pair, and IF3O. This is F, this is F. Okay, IF3, 1, 2, 3, 5. Okay, this is lone pair of electron. Now you just look at very carefully. Here, what we did, like oxygen replaced by fluorine. Oxygen replaced by fluorine means here percentage of oxygen replaced by fluorine. So here percentage of S character decreases. Percentage of S character decreases. If percentage of S character here decreased, means here percentage of S character will be increased compared to here. Here percentage of S character will increase. So if this bond length is x2 and if this bond length is x1, then what will happen? See, x2 is less than x1. Okay, no problem. Clear? Okay, okay, perfect. Now next move to N2O3 and N2O4. N2O3 and N2O4. Let me write first N2 structure. Okay, N2O3. Okay, N2O3. N2O3 and N2O4. Okay, N2O3 double bonded O. This is coordinate bond. N2O3. This is double bonded, and this is lone pair. This is N2O3. Okay, no problem. Okay. Now N2O4. This is N2O4 in double bonded O. This is coordinate bond, double bonded O. This is coordinate bond. Okay, no problem. Okay. Now if you compare this one, what will happen? Okay. See, lone pair will be occupied or preferably in a position where percentage of S character will be more. Okay. See, if here percentage of S character is more, see, compare like oxygen to lone pair. If you move from oxygen to lone pair, what will happen? Lone pair will occupy in a position where percentage of S character will be more. So from here to here, so percentage of S character here is very high compared to here. Here percentage of S character and here percentage of S character will be more. If percentage of S character here, if it is more, then percentage of S character here it will be less. Percentage of S character here it will be less compared to this one. So if this bond length, if this is x2 and if this is x1, then what will happen? X1 greater than x2. Okay, what I am trying to say, see here what we changed, like oxygen replaced by lone pair of electron. Lone pair will be in a position where percentage of S character will be more. If percentage of S character here it's more, then it will be decrease here. If it's decrease, then bond length will be increase. So x1 is greater than x2. Okay. Okay. Now SO bond in SOBr2, SOCl2 and SOF2. Okay. Now let me SOBr2, SOCl2 and SOF2. Okay. SOBr2, SOCl2 and SOF2. Okay. Just write down the structure. SO, this is Br, S double bonded O, this is Cl, This is Cl is double bond O. This is F. This is F. Right? No problem. Now see, bromine is replaced by chlorine. Chlorine is replaced by chlorine. Like we are going from bromine to chlorine and chlorine to fluorine. Okay. So here electronegativity from here to here increases. That means percentage of S character here will be very less. Here to here percentage of S character decreases. So percentage of S character here it will be very less because this is the most electronegative element. So from SOBr2 to SOCl2 to SOF2, if we move, the percentage of S character in SF bond, in this bond, will be very less. So if it is like that, then here percentage of S character will be maximum. Here percentage of S character will be maximum. In this case, percentage of S character will be maximum. So if the bond length now here x1, this is x2 and x3, then x3 will be minimum because percentage of S character is maximum. So x3, x2, okay. So x1 will be the maximum and x3 will be minimum. Done. Okay. Now what is there? Okay. Now one more interesting thing that you sometime might be confused, that if you are given to compare the bond length, look at here. Say ClF3, BrF3, SF4, SEF4, SF6, SF2. In this case, SF6. Okay. In this case, what I am trying to say, listen very carefully, that in this case ClF3 and BrF3, everything is same, only central atom different. Okay, move to ClF3. Okay, show me. Let me show you ClF3. Cl, this is F, this is F, this is F, this is lone pair of electron, this is lone pair of electron. Okay, it will be like this. Okay, and BrF3. Okay, Br, this is BrF3. Okay, this is lone pair, this is lone pair, this is F, this is F. Okay, so it will be like this. Okay. Now see, when the bonded atom will be different, here Cl, and look at Cl and Br, size of Br is more than size of Cl. If size of Br is more than size of Cl, don't look at or don't try to compare with percentage of S character. See, Br size is more, so this one will be the dominating. So BrF bond length will be more compared to the ClF. Don't try to see the percentage of S character. So if it is x2, and if it is x1, then x2 will be of course greater than x1. No problem. Okay, done. Now next move where SF4 and SEF4 same, but same. SF4 and SEF4. SF4. Okay. 1, 2, 3, 4, and it's okay. Sulfur, and this is selenium. Fluorine. This is fluorine. And one there will be here. See here SF bond and SEF bond. Of course, size of Se is more than sulfur, oxygen, sulfur, selenium, tellurium, and then polonium, right? So SEF bond will be more than, longer than SF bond, right? No problem. Okay. Now next move to what is there? SF. Okay. Okay. In this example, look at very carefully. When you are giving like this kind of molecule and you need to compare the bond length, say here bond length A1, say here A2, or say here A3. Say A1, A2, A3. Okay. See, double bond is shorter than single bond. So A1 will be less than A2 or A3. Now, if you, this is the center. Now, if you compare this Cl bond and this F bond, what will happen? This Cl bond and this F bond, what will happen? Means sulfur fluorine and sulfur chlorine. See, size of chlorine is bigger, then this bond will be the longer. So after that you just write A2. After that you just write A1. Okay, A1. Okay, A1. Then you just write A2. Then A3. I mean A3 bond. This sulfur chlorine bond will be the longest one. Okay, A3, and this is the sulfur fluorine bond. A2 is sulfur fluorine bond, and double bond will be the lowest one. No problem. Okay, done. Now, one more interesting example like PCl5 and PCl3F2. Let me show you that one. PCl5 and PCl3F2. Okay, PCl5 and PCl3F2. Okay, first draw the set. Okay, P, this is Cl, this is Cl, this is Cl, this is Cl, this is Cl. Now PCl3F2, chlorine will be in the axial positions. Okay, Cl, this is Cl, and this is Cl. Now what I am going to compare, you just look at here. Okay, if I want to compare this axial bond and this axial bond, don't get confused. This axial bond and this axial bond, what will happen? The size of Cl is bigger than size of fluorine, so this axial bond will be longer than this bond. Okay. Okay. Now, okay, say this bond is L1 and this bond is L2. First compare this one. L1 and L2. See, here percentage of S character is less because this has pdz square orbital and here it is sp2. So percentage of S character is more. So L2 is less than L1, right? If you compare L1 and 2, it will be like this. Now compare here. Say this is L3 and this is L4. This is L3 and this is L4. If you want to compare this L3 and L4, don't get confused that this bond will be longer than this bond because here L1 is longer than L2. No, size of fluorine is smaller than size of chlorine. So this one will be more. L3 will be in this case more. L3 will be more than L4. Right? No problem. So don't get confused with this one. Okay. Now next move to this one. This example is very interesting example. Sometimes you will be very confused to compare the bond length here in PF4Cl and PF3Cl2, the axial bond and equatorial bond. I have given you the data. Now you need to compare that. Here the equatorial bond, in this case PF equatorial bond, and here the PF equatorial bond, how it will be changed. Let me show you. See, here PF equatorial bond is 153.5 PF. Here PCl is 200 picometer. Here it is 153.8 and 200.2 picometer. Means here to here the percentage of bond length, equatorial bond length PF and PCl increased. Now how it increased? Okay. In order to explain this one, what I am going to do, I am going to take some arbitrary data. Let me take some arbitrary data. Okay. What the data? Okay. if I take here percentage of S character will be more compared to, I mean in PCl bond percentage of S character will be more compared to PF bond. Let me take here that percentage of S character here is 40%. So total will be 100%. So 30% this one, and here it will be 30%. Okay, no problem. Now if you move from here to here, what happened? Fluorine get replaced by Cl. Say keep here 40%. Don't disturb that one. 40%. If you replace fluorine by chlorine, what will happen? What will happen? The percentage of S character will be increased. Percentage of S character will be increased because it is less electronegative element. So 32, say percentage of S character increases, say it is 32. 32 increases. 2% increases. Now question is, the 2% whatever it get increased, whatever 30% it get increased, you just do one thing. You just fluorine will try to be in a orbital where percentage of S character will be less. So here you just decrease the percentage of S character. Think like this way. See, I am taking just arbitrary data. Just I'm actually trying to explain this one, how the bond length will get changed. Now what will happen? Now look at very carefully. This 40% and this 32% average, if you take the average, can't I write that this is 72 divided by 2 is equal to 36%? I can write, right? So here percentage of S character now will be 36%, and here percentage of S character is also 36%. Okay. Now you look at the bond. See, initially PF bond percentage of S character was 30% in this structure. Now from here to here in this structure it is 28%. 28%. So percentage of S character what? Decreases, means bond length will increase. See, 153.5 to 153.8. No problem. Perfectly alright. Now if you see here percentage of S character is 40%. 40%. Here what will be the percentage of S character? 36%, by the way. 36% means here also percentage, average percentage of this character in PCl bond decreased. If it is decreased, means bond length will increase. So here also 200 picometer to it will increase to 200.2 picometer. Okay, right? This is very interesting example. This is very interesting example. I am actually explaining this one on my own way. Just try to, put like percentage of S character like this way, and try to you just do it by yourself. Then I think you will be feeling comfortable and you can interpret the data very easily. Okay, so I think okay, no problem. Okay. This is all about the bond length comparisons using Bend rule. So thank you so much.